lesson day 3 of the Unit Circle supplement. The learning targets for this lesson are that you will be able to find all angles with special reference angles 30, 45, and 60 degrees. And you'll be able to find trigonometric ratios of special angles on the coordinate plane in the first quadrant with a hypotenuse of 1. This lesson sets us up to build, or sets you up to be able to build a complete unit circle in degrees when we meet next. So, we're going to look at this first one. On the coordinate plane, sketch all possible angles that have a reference angle of 30 degrees. This is to be done without a calculator. Well, the first one's easy. 30 degrees is roughly here. That's easy. Now the other angle down here, this is easy too. That would be negative 30 degrees, which would be equivalent to negative 30 plus 360, which would be 330 degrees. So I have this one, and I'll do that other one in a darker blue color. That would go all the way to here. So that also has a 30-degree angle, a 330. Matching that over here, we'd have to have the same angle roughly. If this is 30 degrees, then 30 minus 180 is 150. And then if I put the 30 degrees here, that's actually 180 plus 30. So 210. No. Yes, 210. So the angles equivalent to the 30 degrees are 30, 150, 210, and 330. I actually could calculate these without drawing it in the coordinate plane, but for now I was drawing it just so it made sense as well in terms of how it's related to the different quadrants. For the 45-degree angle, I'm going to start in quadrant 1. That's going to go right down the middle, and then it would drop. Same thing here. It's going to go right down the middle and drop, right down the middle and come up, right down the middle and come up. So this is 45 degrees. Theta prime is 45 there in quadrant 2. Theta prime is 45 there in quadrant 3. Theta prime is 45 there, or the reference angle is 45 in that quadrant 4. In quadrant 4, that's like negative 45 or 360 minus 45, which is 305 degrees. So if I went all the way around to here, that would be 305 degrees. In quadrant 2, that's almost 180, except we don't want this 45-degree angle to go from here to here. We would do 180 minus 45, which will be 135. Need to be able to do this without a calculator. Okay, so then to go all the way into the third quadrant, I'd have to do my 180 plus an additional 45 degrees, which would give me 225 degrees. So my angles are 45, 135, 225, and 305 degrees. Those angles all have a reference angle of 45 degrees. Try this for the 60-degree angle. All right, welcome back. Well, in quadrant 1, you had 60 degrees, which you knew was the reference angle and equivalent to the actual angle in quadrant 1. Over here, this is 60 degrees, so it's everything except for 180. So 180 minus 60 is 120. To go all the way here is 120 degrees, since 120 plus 60 is 180. To go almost all the way around the circle, so almost all the way around the circle, and have this 60 degrees left here, that is 300 degrees, because 300 plus 60 is 360. And then going here is 180 plus the additional 60 degrees, 180, and 60 is 240 degrees. So our angles for that have a 60-degree reference angle are 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Those are the ones that give us ratios equivalent for sine, cosine, and tangent of 60 degrees. The 120, the 240, the 300. Now there will be some things with the sine that we observed in the last lesson, depending on which quadrant we're in. Sine, cosine, or tangent will be negative. Same thing with the 45. When we have either a 45, 135, 225, or 305 degree angle, and we're doing sine, cosine, or tangent, we need to reference our special right triangle and know what sign is attached to it depending on the quadrant. And the same thing with 30 degrees. So if you see 30, 45, or 60, we need to use our special right triangles or our knowledge of what those ratios are as an exact simplified radical form. Sketch each angle on the coordinate plane so that it will form a right triangle with the hypotenuse of 1. Then state the reference angle and find the sine, cosine, and tangent of the angle. So here's the coordinate plane. 30 degrees is roughly here. And we know, they said let the hypotenuse be 1. Well, for our special right triangles, for a 30, 60, 90, this was 1, this was 2, and this was the square root of 3. Which means we've now just divided every one of those sides by 2 in order to get the hypotenuse to be 1. Which means that this is 1/2, and this is square roots of 3 over 2. So we are supposed to go through and find the sine, cosine, and tangent. We could have also done sine, cosine, and tangent of this and reduced it. It would have done the same thing, but this was the specific direction that we're following. So sine of 30 degrees, when the hypotenuse is 1, or another thing, that would actually be the radius of our circle when the radius of our circle is 1. So sine is opposite over hypotenuse, so 1/2 over 1. So 1/2 divided by 1 is 1/2, or 1/2 times 1 over 1 is 1/2. Same ratio we would have gotten here, 1 over 2, 1/2. Cosine of 30 degrees is adjacent over hypotenuse, square root of 3 over 2, over 1, which is still square root of 3 over 2. And tangent of 30 degrees is opposite over adjacent. So 1/2 divided by square roots of 3 over 2. How do you divide by a fraction? You multiply by its reciprocal. So instead of dividing by square root of 3 over 2, we're actually going to multiply by square root of 3 over, and by 2 over square roots of 3, because we have to multiply by its reciprocal. So this is actually times 2 over square roots of 3. 2 over 2 is 1, so this is 1 over the square root of 3. That's not simplest radical form though. We have to rationalize the denominator. This gives us square root of 3 over 3, which is what we would have gotten if we used this triangle. We would have had 1 over the square root of 3, rationalized our denominator, gotten the same value. We're now supposed to do this for a 135 degree angle. That angle sounds familiar. Let's take a look and see which one it was. 135 degrees has a reference angle of 45. And if I didn't remember that, I could see that when I drew it in the quadrant. So 135 going to quadrant 2, 180 minus 135 is our 45 degree angle here. This is supposed to be a 1. Well, if you remember our special right triangle, the 45, 45, 90 was 1, 1, square root of 2. So that's a little different because square root of 2 is bigger than 1. So basically they divided all these sides by square root of 2 to get this. So this was divided by square roots of 2 to get the 1, and so is this. This is 1 over square roots of 2. This is 1 over square roots of 2. I know I can't leave it like that, so I'm going to rationalize that denominator now. Square root of 2, that's square root of 2 over 2 for both of these sides. So I have square root of 2 over 2, square root of 2 over 2, and 1. So now the sine of 135 degrees. Oh, I have to be careful. There's something that I wrote incorrect. We're in quadrant 2. And our xy coordinate for this point right here, if the radius or the length of the hypotenuse is 1, the height is square root of 2 over 2. That's fine, but I went left square root of 2 over 2, so this should actually be negative square root of 2 over 2. So that means that sine of 135 is opposite over hypotenuse. That is positive square roots of 2 over 2 over 1, which is just square root of 2 over 2. Cosine of 135 degrees is adjacent over hypotenuse, so negative square roots of 2 over 2 over 1, which is just going to be negative square roots of 2 over 2. And tangent of 135 degrees will be opposite over adjacent, opposite over adjacent, square roots of 2 over 2 divided by negative square roots of 2 over 2, or rather multiplied by the reciprocal value times 2 over square roots of 2, and that thing is negative. So the 2 over 2 becomes 1, the square root of 2 over square root of 2 becomes 1. 1 times negative 1 is negative 1. So in this quadrant, we see that sine is positive, cosine is negative, tangent is negative, just like we saw in our lesson on day 2 when we looked at the signs of sine, cosine, and tangent in the different quadrants. I'm going to repeat this. I'm asking you to repeat this for these other values and see if you can then answer these questions. I will do one more of these. Let me find which one I want to do. I'll do the, not the 150, let's do the 300 degrees. 300 degrees is equivalent to the 60-degree reference angle. The other ones I'm going to ask you to do. So 300 degrees is in here, so that goes all the way around, and here's theta prime, our reference angle, the 60-degree reference angle. And so for that, this is 1. So again, I'm going to draw a 30, 60, 90 triangle in that same orientation. Here's my 30, here's my 60, here's my 90. For the one we memorized, it was 1, 2, and the hypotenuse was the square root of 3. The only thing is now the hypotenuse is 1 instead. So they just took all of these terms and divided them by 2 to create the triangle that we have right here with a hypotenuse of 1. So this is the 1/2, and this is the square root of 3 over 2. Using similar triangles. So we're supposed to find sine, or we're supposed to find all 6. I thought it was just sine, cosine, and tangent. Yes. Sine of 100 or of 300 degrees, cosine of 300 degrees, and tangent of 300 degrees. Sine of 100 degrees will give us, or 300 degrees, sorry, 300 degrees, so the reference angle of 60, will give us opposite over hypotenuse, which is square roots of 3 over 2, divided by 1, which is just square roots of 3 over 2. Cosine of 300 degrees is adjacent over hypotenuse, so it's just 1/2. Tangent of 300 degrees is opposite over adjacent. So square roots of 3 over 2 divided by 1/2, which is really multiplied by the reciprocal times 2 over 1, gives us the square root of 3. I have to be careful though, I forgot to do something again. And I always check at the very end to make sure my signs make sense. I'm in quadrant 4. Well, in quadrant 4, not all of these are positive. And that's because the square root of 3 over 2 is negative. It's going down. So my sine should have been negative. My cosine was okay to stay positive. My tangent should also be negative. Signs are important. Depending on which quadrant you are, will affect whether sine, cosine, or tangent are positive or negative for their ratio. There are other ways to do this that we'll be looking at in class, but right now I want you to try these. I'm going to ask you to try C, D, and E on your own, and I'll give the final reduced answers in just a moment. But please pause the video and try those. For letter C, you should have started with your negative 225 degree angle that you drew, and then realizing that you need to work in an angle between 0 and 360, you found the coterminal by adding 360 degrees to it to get 135 degrees. Using the reference angle of 45 degrees, which is the reference angle for 135 degrees, and your special right triangle, which you divided every side by the square root of 2 to create, gave you square root of 2 over 2 for the height, negative square root of 2 over 2 for going left from the origin, and 1 for the hypotenuse like was directed in the directions. Then doing sine, cosine, and tangent, these are the values you should get. Notice that tangent and cosine are negative just as you found in number 3 of your day 2 homework. For letter D, doing 120 degrees, you know the reference angle is 60. You could find that on your own, but you know that 120 went with the reference angle of 60 from what we did on the first page. Using a hypotenuse of 1, which normally it's 2, that meant we had to divide everything by 2. So 1 had to be divided by 2, square root of 3 had to be divided by 2 to give us our side lengths. Going left means that this is negative. Going up meant that was positive. The hypotenuse is always positive. The hypotenuse is always positive. So doing sine, opposite over hypotenuse, gave us this. Cosine, adjacent over 1. And tangent, square root of 3 over 2 over negative 1 over 2, which was multiplied by the reciprocal of negative 2 over 1, gave us negative square roots of 3. And that matches what we looked at in problem number 3 of day 2, that the sine would be positive in quadrant 2 and the cosine and tangent will be negative. Also, that's what happened in letter C. For letter D, drawing the 150 degree angle, we know the reference angle is 30 degrees. They want a side length of 1 instead of 2, so we divide everything by 2, giving us a short leg of 1/2 instead of 1, and negative square roots of 3 over 2 instead of negative square roots of 3, since we are going left. Sine of 150 degrees is opposite over hypotenuse, giving us 1/2. Cosine of 150 degrees, negative square roots of 3 over 1, giving us negative square roots of 3 over 2. And the tangent of 150 degrees, being 1/2 divided by negative square roots of 3 over 2, we multiply by the reciprocal, 2 over negative square roots of 3, which gave us 1 over negative square roots of 3. Rationalizing that denominator gives us negative square roots of 3 over 3. Once again, we're in quadrant 2. We were also for C and D, where sine is positive, cosine and tangent are negative. Please take a moment to answer the questions below to the best of your ability. You may have to reference what you learned in lesson 2, including number 3 from the homework. Have a great day.